boys and girls, we pick up with this. We're going to kind of do two learning pieces today. Number one, we're going to do power reducing formulas. And we're also going to be doing sum to product and product sum formulas. So I'm just going to give them to you. Sine squared of x, we learn, is equal to 1 minus cosine of a double angle 2x divided by 2. We also learned that cosine squared of x is equal to 1 plus cosine of 2x all over 2. And finally, we learned that tangent squared of x is equal to 1 minus the cosine of 2x divided by 1 plus the cosine of 2x. Why do they call it lowering powers? What's that? Getting rid of the squared. So it goes from a squared down to a single degree. When is this useful? Primarily in calculus. Raise your hand if you anticipate possibly majoring in something that involves science or math or medicine or anything like that. Okay, so there's a pretty decent chance that you would take calculus 2. I would say that these power reducing formulas probably come into contact most in calculus 2. It's a really good time. Call me if you need help. So here's the other thing. What else do you notice about all the formulas? They all have cosine. So it's kind of interesting, and it's rather nice that they share that in common. They all involve cosine, okay? And so if you look at your formula sheet, you can see here that we are in the power reducing section. This is where they're located. So yesterday we did half angle and double angle. The day before that we looked at cofunction. We looked at sum and difference. We saw even in odd identities right away. All these are from previous units, and then the bottoms are from previous units as well. So after this power reducing, which we're going to do right now, all we have left is really our sum to product sum formulas, which are actually a lot easier than our power reducing ones. So I think it'd be good to go. So this is the sheet, and this is what you're given on the test, along with the other side that has some of these formulas written as well. You may consider color coding them, as I said, so you remember where to go at what time. But right now, we're living here. Everybody see that? Okay, so let's try the problem. Not in real life, but in calculus, it's often nice to rewrite squareds as single powers. So we like to reduce the power, and it makes life a lot easier in calculus. So we want to rewrite the following expression in terms of first power of cosine. So that means that I cannot have a power other than 1, and I cannot have a function other than cosine. What should I do first? What is sine squared? Okay. We'll need to multiply those out. 1 times 1. Negative cosine of 2x times 1. Negative cosine of 2x. 1 times positive cosine of 2x is positive cosine of 2x. And negative cosine of 2x times positive cosine of 2x is negative cosine squared of 2x. All over 4. Negative cosine 2x and positive cosine of 2x cancel because they are conjugates of each other. Therefore, we get that. We get 1 minus cosine squared of 2x all over 4. Oh no, what do I do now? This is cosine squared, isn't it? So I have to do it again. The only difference is, instead of an x, I have a 2x. It's going to require a new formula. Let's try to come up with a formula on our own. We have a formula for cosine squared of x. Let's come up with a formula for cosine squared of 2x. let's try to look at the pattern and then go from there. What happens to the angle each time in each of the formulas? It gets doubled, right? So instead of a cosine of 2x, you're going to end up with a cosine of 4x. Everybody see that? We have 1 plus cosine of 4x over 2. So I will insert that formula. 1 minus the quantity, 1 plus the cosine of 4x over 2. All over 4. And I leave my answer like that. Why not? It's a complex fraction. In order to take care of the complex fraction issue, I must find common denominators in the numerator and combine them into one fraction. So I will make this a 2 over 2. And I get 2 minus 1. I'm going to distribute my negative sign all the way through. Minus cosine of 4x. All over 2. All over 4 over 1. Can I combine any terms together? 2 and 1, so I get 1 minus cosine of 4x divided by, multiplied by the reciprocal, multiplied by the reciprocal, and it's divided by 8. Get rid of the 4 over 1 by multiplying by 1 over 4. 4 times 2 is 8. Now, I will give you 3 options as to how you can leave your answer. Number 1, you can leave it like this. Second of all, you could leave it as 1 over 8 minus 1 over 8 times the cosine of 4x. So I just divided through by 8. Or you can factor the 1/8 out and write it like this. Now you're getting angry and saying, my teacher is showing me many ways to do things that I just won't want. Well, I like to write it probably the first way. I think that the book likes to write it the last way. And some students like to write it the middle way. It's America, free country, make your own choice. You should be able to recognize that all these expressions are equivalent. Are we okay there? So I would say that yesterday we saw the most common question, the double angle question. It's the most common response for IDK on the test. This would be the second most common time where I get IDK on the test. Okay? Let's try another one. And I promise you guys, on the test, it's going to be a problem you've done before. I mean, we're not going to do sine to the 16th times cosine to the 16th. It takes the better half of a semester in order to figure that out and get it accurate. So, you will have seen the problem before. You just have to go carry it out on your own. So we do sine to the 4th. We know what to do now. Sine squared times sine squared. Sine squared is multiply that out. 1 times 1. Negative cosine 2x and negative cosine 2x. And then negative cosine 2x times negative cosine of 2x would be positive cosine squared of 2x. You don't do anything with the angle. You just leave the angle alone. All over 4. Am I done? Done. Cosine squared, so I must insert something else. So 1 minus 2 cosine of 2x plus, oh no, cosine squared of 2x, need a new formula. Fortunately, we made one, right? We've got 1 plus cosine of 4x all over 2, all over, I don't know, I have a complex fraction. Let's just do it. I got in trouble first hour. I want to skip a step here. Okay. I need to find common denominators. So 1 can be written as 2 over 2 minus, you create a common denominator of negative 2 cosine of 2x, be negative 4 cosine of 2x over 2 plus 1 plus cosine of 4x over 2 all over 4. Are you okay if I write the denominator as 4 over 1? What terms can we combine in the top numerator? What do you want to make? 3? Now that should be positive. I'm sorry, I wrote the negative twice. Sorry about that. We have minus 4 cosine 2x plus cosine of 4x all over 2 over 4 over 1. And as you guys said right now, when you multiply by the reciprocal, you end up with 3 minus 4x. Whoop, or cosine of 2x. Plus cosine of 4x all over. Cosine 2x and cosine of 4x cannot be combined. No. Right? You can't add them, you can't multiply them. Just to be clear, in your assignment, at some point in your assignment, you might end up with this situation. You might end up with, say, 4 cosine of 2x times 8 cosine of 4x. It just might work out that way. And I just want to be clear that if the angles aren't the same, you can't combine them. You can't write them as squareds. So this only simplifies to 32 cosine of 2x cosine of 4x. So in your assignment, you might end up with that situation. Just be prepared to, but this is sufficient. First powers of cosine. Okay, that's what the direction states. Got that? That is the last, what I would say, insurmountable piece for people within the trigonometry course for this unit. And what I mean by that is I will inevitably have people throughout the year that will get to this type of topic, okay, lowering powers, power reducing, and come test time, they'll say, I never knew how to do that. They just weren't able to ever figure it out. Okay, maybe they didn't come in for help, maybe they just never got it, whatever. The other one would be that double angle formula piece. Okay, so everything from this point forward, I think is doable for everybody. Okay, I think it only gets easier from here on out. Okay, for this unit. Okay. For this unit. Okay, so let's do one more small piece together. Please make sure you can reference your formula sheet. That will call us good to go. Sum to product, product to sum formulas. There are 8 of them written on your notes. You do not have to memorize these, and in fact, you won't use these very often. They do come up every once in a while in calculus. The reason why I'm showing them to you is twofold. Number one, if you see them in calculus, at least you'll have a basis for seeing them before. And second of all, it creates some nice, easy points for you to get on the test. Okay? So the test is weighted with a material that you guys generally find rather challenging. So I threw a piece in there as well that this can get you some easy points on the test. Okay? I think that that's a reasonable attitude to have and to approach with. Um, I also want you to know that this formula sheet that you were given is a formula sheet that people do tend to keep year from year. If you head on off to college next year in 2 years, it's like, boy, I sure wish I had that, sheet that had all the trigonometry formulas on there. Just go ahead to my website, print it off, or email me. I probably get at least half a dozen people every year that contact me and say, hey, I'm taking calculus at, wherever. I need those sheets. Please send them to me, and I do. I probably get a few people every year, too, who are taking calculus at college, and they go to the lecture each day, but they don't pay attention to the lecture. Instead, they go and find my YouTube videos, and they find the same unit that we're doing, and they just follow along with that instead. It warms my heart that they do that, but sometimes they can't understand the professor, and sometimes in a group of 400 kids, they find it difficult to learn, so they watch a video instead. You're on your own. You can do whatever you want. So just know that if you need some help, just email Mr. Gens. Okay? I'll be there for you. All right. So let's locate our product to sum and sum to product formulas. They are in the red right here. Everybody see them? Okay. I do not remember all these. I have to continually look them up because they look very similar. As you can see, kind of what changes, the cosine or the sine and the plus or the minus. And so we're going to just write down two of them for good measure so you can say I located them. So let's look at this first one. It says product to sum formula. So I have a product, and I would like to figure out how to write it as a sum. So using either addition or subtraction. It looks like I have sine and cosine. So let's look at our page. Which one is it? First, second, third, or fourth one? So as I look, I'm looking for product to sum. So it's going to be this one. And it's sine times cosine. It is the third one right here. So I'm going to write that one down on the front of the page. So you don't have to remember them, but you need to locate them and write them down. So let's see. We got 1/2. We got sine plus and sine minus. Got it. You guys got to make sure I get it right. Okay. 1/2 times sine of the two angles added together plus sine of the two angles subtracted. Is that right? Okay. Great, that's my formula. Let's find the next one. Sine of A plus sine of B. I would like to take it from a sum and write it as a product. So right now it's a sum. I want to write it as a product. Which formula is it on the sheet? It is the first one under the sum to product. It looks like it's 2 times sine of the average of the two angles times cosine of A minus B over 2. Okay, so it's sine plus and cosine minus. Is that right? Okay, great. So, you know how to locate them, right? Let's put them to use. It says the rest are located on your sheet of formulas. It says write the following product as a sum. So I want to take it as a product. I want to write it as a sum. Do we already have this formula written on the board? Great. So I'll write it down. 1/2 times the sine of A plus B plus the sine of A minus B. What is A in this problem? 4x. What is B? 2x. So I have 1/2 times the sine of, what do I get if I add the two together? 6x plus the sine of, what do I get if I subtract the two? 2x. If you want to distribute the 1/2 through, you can. You could get 1/2 sine of 6x plus 1/2 sine of 2x. But you may not multiply the 6x or the 2x by 1/2. But I would accept either of the bottom two answers. That's all you have to do. That's it. The point is, you wrote it from a product to a sum. And so what we will end with today is you will be able to find the exact value of that product. So we will apply it in a certain way. Guys, you were so happy originally. Just don't get... Yeah, well, yes. That would be fine as well. Yep. Okay. Any of the above is fine. All right, let's do the next one. What's different about this problem? The 3 is in front. No big deal. 3 comes along for the ride. It's just a constant. Okay, so we'll just multiply the end result by 3. I have to locate this on my sheet. I have no idea what cosine times cosine results in, so I'm going to check it out. Look at my product. I have cosine times cosine. Looks like I have cosine minus and cosine plus. Okay, we'll do that. Cosine minus and cosine plus. Is that right? Well, look at your sheet, because I don't see mine. So it is? Okay, great. All right, so we're going to multiply the entire thing by 3. So I got 3 halves, correct? And what is A in this problem? A is x and B is 2x. So I have the cosine of what is A minus B? Negative x. Plus the cosine of what is A plus B? What's the problem? What am I not allowed to have in trigonometry? A negative angle. Now, what happens with the negative angle for cosine? It goes away. We use our what's referred to as our even odd identities, which is right here. That I think you probably committed this one to memory, haven't you? That cosine of a negative becomes a positive, and secant of a negative becomes a positive, whereas all the others you can see that there's a negative value that is distributed out front. So, I said distributed, it's not like it's multiplication or anything like that, it's just you try to think about what's happening. We could do a proof, but okay, all right, we'll just trust it's fine. So I'm going to rewrite this then as 3 halves times the cosine of positive x plus the cosine of 3x. So that would be one way to write your final answer. Everybody okay with that? If you would like to distribute the 3 halves, that's fine. If you would like to distribute the 3 and divide everything by 2, that's fine. There are about 4 different ways you could write that. Okay, take 2 more left, or 3 more left. Write the following sums as products. Now I'm going opposite. I'm going to take the sums and write them as products. So I got sine minus sine. I'm going to look it up. Second one, sine minus sine. So I got 2 cosine plus, sine minus. Cosine plus, sine minus. Plus, sine minus. Cosine plus. Sine minus. Super-duper. We got it right? What's A? What's B? Add them and divide by 2. Yep, so we get 4x over 2 is 2x. Excellent work. And sine of x. Done and done. You'll like that, don't you? Thank you, Mr. Gibbs. Such great information. Self-promotion? What'd she say? Star qualities? Good point. Should do that tomorrow. I know. All right, you do. So, alright, since you brought it up, you gotta have one. Wow, she just throws her on the spot. It's like, boom, take this. Star qualities tomorrow. Save it. Alright, here we go. You do next one on your own. Go, go, go. Next one on your own. Run. Go. What? Oh, you want me to put my formula sheet up? Did I not staple one to the back of your notes? Yes, I sure will. I was just wondering if it's just kind of a lazy day. Okay, lazy day. Got it. We all lazy days, I get it. Well, not everybody. just ask what is math, not math. Is that your formula? Oh, is that your formula? Okay, so we get -2 cosine. Is it really? I would use the word hate to describe my feelings towards you guys, but it is too strong, so I will say loathe. I loathe you guys. Loathe. Like, I loathe fried onions. Ugh. It is. It is. I'm waiting for somebody to turn me in, so. Stay above the line. Yeah. Everybody just shut up! I'm tired of this! just have random just go off day. I know, he can't hear you guys, so they're like, what's going on? Okay, for all the YouTube people, I am literally being verbally assaulted by my group right now. And just for the record, I'm going to name names. Brishi is over the line. She looks worried. She looks genuinely worried. Okay, and so for people who are wondering, when the phone goes off in my class, I answer it and I say, against his room, we do math. And so apparently Miss Nelson tried to copy me on this last year. She said too quickly. She said, Nelson's room, we do math. But it sounded like math. So then everybody thought it was a drug class. Nelson the drug lord. Oh. Yeah. Exactly. You get bored during the summer, you're going to find this one. All right. Well, add them and divide by 2, so you get 11x over 2. And then sine of, yep, 5x over 2. And that's it. Yeah, that's fine. 11 over 2x is fine. Yep. Okay, so let's do this one. We're not going to do the last one. It doesn't work out very well. But we will do the find the value of the product or sum. So sine of 105 times the sine of 15. When you see a problem like this, something needs to resonate in your brain that you don't know the exact value of sine of 105. You don't know the exact value of sine of 15. So if you wanted to, you could do the sum and difference formula twice. So for example, sine of 60 plus 45 and sine of 60 minus 45. You could separate it, do that twice. That's fine. Or you could take a chance and try to rewrite it as a sum. So sine times sine. Do I have that up here? I don't. So I'm going to have to locate that on my sheet. It is the first one under product to sum. So I got cosine minus cosine plus. Got 1/2 times cosine of A minus B minus cosine of A plus B. Is that correct? So first of all, it's all multiplied by 3, so I'm going to have what out front? 3 halves. And then what is A? And what is B? So I have cosine of 90 degrees minus the cosine of 120 degrees. Well, that works out pretty nice because I know the exact value of cosine of 90. What is the terminal point on the unit circle for 90? 0, 1 is cosine the x value or the y value. X value. So you have 3 halves times 0 minus, and now I need 120. 120 creates that terminal point, which is going to be -1/2 and root of 3 over 2. You guys know how to do that because you're super smart. And so what's the exact value of cosine 120? A 1/2. So you end up with 3/2. Right, like I care. 3/2 times 1/2 is equal to 3/4. What? Sorry, Dan. This is difficult for everybody. Okay, Brooke, you got a question. Well, so I have the 3/2 here, right? What's 0 minus the negative 1/2? Positive 1/2. 3/2 times 1/2 gives me 3/4. The answer is 3/4. Okay, so your assignment, 7.3, page 557, numbers 9 to 12. Those are the hard problems we did originally. Class gets over today at 11 o'clock. No, nice try. 108. 108. Okay. Those are the easier problems like we just did. Siren, first Wednesday of the month. And so just so YouTube Nation can hear this as well, I want you guys to know that I think you have a wonderful class. I really do. That said, I want you to know that between you and calculus, you are covering the most challenging material that you've seen during the course of the year. If you don't find any of it challenging, good for you. I just want to let you know that if I back up 4 years ago and I look at my classes that were doing this material, and they were sharp kids too, I would say I had people in my classroom probably every single morning. So right now I finally have 2 kids from calculus coming in for help tomorrow. But I would just encourage you, if you don't know what's going on, you might have to stop in for help. I get a lot of conversation during that time. A lot of people may say it's not possible for me to come in the morning, or it's not possible for me to come in after school. That's fine. Good luck. I don't know what else to say. I mean, find a good study partner, watch videos. I mean, it's all I can do is be available when I'm available. I'm available before school. I'll be here tomorrow at 7:15. The videos are available. If you don't want help from me, then I guess you got to figure it out on your own or find a good person who can help you out. So there's a lot of people that know how to explain the material too. So just want to encourage you that if you do need help, I'm a great resource.